Hey guys, it's been a while since you've seen a video, had a little bit of a break, but we're going to do something a little strange. We're going to start on Chapter 4, even though we're not done with Chapter 3. I know, crazy teacher. So today we're just going to be talking about estimating again, but this time we're going to be talking about estimating products of fractions. So estimation, good technique. We can use it for all operations, for all types of numbers. And if I could spell fractions, that would be better. Oh, my. Today's date is going to be 9/26/18. Okay, so we're going to talk about a term that I think some of you may have heard before, and that's called compatible numbers. So sometimes when we do estimation, we just round to the nearest whole number, the nearest tenth, or whatever we decide is going to be our best way to estimate. We have a rule: 4 or less, number stays the same. 5 or higher next door, it's going to move it up by 1. Compatible number says, okay, let's do this an easy way. Let's find a number close to one of the numbers that another number can go into evenly. So let's write down a definition and we'll do an example. So compatible numbers. So basically, compatible numbers is when you substitute a value for a number or numbers for a value for a number of numbers to make the math easier to solve. Okay, so for example, let's talk about if I have 127 and I want to divide it by 32, if I rounded both to the nearest 10, I get 130 divided by 30. Well, 3 doesn't go into 13, so what I'm going to do is just like I would do in a division house. I want to see how many times 3 can go into 12. Now, 3 actually can go into 12 evenly, so instead of dividing this to 130, I'm going to divide it to 120, and the divisor would be 30. That's going to make the math super simple to do. So when they both end in a 0, I can cancel those out, and 12 divided by 3 is 4. So that's how I would get that answer. That's approximately 4. Okay? So what we're going to do is talk about using compatible numbers to estimate. In fact, I'm going to give you 2 strategies. So we're going to do that. So using compatible numbers to estimate. And then we're going to do a little twist, and we're going to take those compatible numbers and we're going to make a model of the problem. So use a model to estimate. Now again, we don't just make a model, we're going to use a model and the compatible numbers together. So let's do this as our master problem. 1/4 times 13. So what I'm going to look at is the denominator of the first fraction, and then I'm going to look at the whole number. So in the examples that we're going to talk about right now, it's always going to involve a fraction and a whole number. Okay? And then on another screen, eventually we'll talk about, well, what if we have 2 fractions? So how would we estimate if they're both fractions? Okay. All right, so compatible numbers. 4 doesn't go into 13, but guess what 4 does go into? Since this doesn't work, let's think of a number close to 13 that 4 can go into. And we just kind of think about it real simple, 4 can go into 12. So what I can do is say, all right, we've got approximately 1/4 times, and I can make any whole number a fraction by giving it a denominator of 1. Now, I'm going to show you 2 ways to solve this problem. First, I can just multiply straight across. Oops, sorry. And I get 12 over 4, which would be approximately 3. Okay? Now, let me show you an alternative. When I'm at this stage, what I can look for is there anything in one denominator that can divide evenly into the other denominator? What is their common factor? So if you notice, 4 can divide into itself once, and 4 can divide into 12 13 times. So now when I multiply straight across, I get 3 over 1, which equals 3. So that's a different way. So I call that pre-reducing, when I look for common factors, numerator to a denominator, and I divide them out first, then I multiply straight across. Okay, so how can I take this exact problem and use a model? Well, I'm going to use that compatible number for 13, which we said was 12. And the bar is going to represent that whole number 12. Okay? Now, the denominator of the other fraction is going to tell me how many places, or how many little boxes are going to be inside of my big model bar. Okay? And now I have to use a little bit of thinking power. If I have 12 split into 4 equal pieces, how much am I going to have in each of those pieces? Yep, we're going to have 3. So the 4, so let me write that problem out here again. So this is what I get when I estimate or use a compatible number for 13. So the 12 is going to represent the whole bar. So that's his job. And the 4 represents how many equal sized pieces we're going to break that bar into. And then we just use logic. If they're 4 equal pieces and they total up to 12, each piece would have to equal 3. Now comes the role of the numerator. It says, I'm interested in one of those 4 pieces. So that's how I get my answer, that 1/4 times 12, that's my approximated problem, would equal about 3. So 2 different ways to use compatible numbers. One, just straight out create a new problem that you can do math real easily. Second is to create a model. So on the next screen, we're going to do a couple of those, and I'll do one of each style again, and we'll just say estimate. So we're going to change up, not just have a 1 in the numerator, we're going to have a 2 this time, and we want to multiply it by 16. So regardless if I want to do the model or I don't, I still have to come up with a compatible number. So what I'm looking for is, what's a number that 5 can go into that's close to 16? And pretty easily we'll say, hey, that would be 15. So really what the problem becomes is 2 over 5, notice the fraction's not changing, is approximately, or times 15, excuse me. I'm going to give that a denominator of 1. So I can multiply this out and get my answer, but let's do a diagram on this one. So remember what the whole bar equals. The whole bar equals that compatible number of 15, so from edge to edge. Okay, next up, remember what we're looking for? We're looking at that denominator. That's going to tell us to make 1, 2, 3, for 5 equal-sized pieces. Now I know they don't look equal-sized, but just pretend. Okay? Now, how many times does 5 go into 15? And that would be 3 for each of those equal-sized pieces. Now comes the fun bit. Remember the numerator? It's telling us how many of those equal-sized pieces I'm going to fill in. So basically what I can say is I have 2/5 times 16 is going to be approximately equal to 3 and 3 together, which would give me 6. Okay, so that's if I decided to use the model. Let's do one without the model. Let's do 5/6 times 13. So again, where we're going to put our focus is right here, denominator to the whole number. And I want to find a compatible number for 13 that 6 can go into evenly. And we're going to be able to say, that's pretty easy, that's going to be 12. So what we're going to end up with is the problem 5/6 times 12. So this is my approximate answer. So I'm going to give it a denominator of 1 to make it a whole number. And I'm going to show you the 2 ways to solve this problem. So I'll break it up with some arrows here, this way and this way. And the first way is let's just multiply straight across. So we have 5 times 12 over 6 times 1. And that gives us 60. These are all approximates. Over 6, which gives me approximately 10. Okay? Now remember what the other way was. We're going to take the 5/6 times the 12 over 1 and look for somewhere, some numerator to some denominator, a factor they have in common. Well, 6 goes into itself once and into 12 twice. So now when I multiply straight across, remember this is estimated, 5 times 2 is 10, 1 times 1 is 1, and that gives me the answer of about 10. Okay? So, different ways, still using compatible numbers. All right, I'm going to go to the next screen and talk about what if I have a fraction times a fraction. So, this would be estimating the product of 2 fractions. So what we're going to do is, because they're fractions, compatible numbers are going to be a lot harder. So what we're going to use is the notion of, all right, we're going to pick 3 numbers that we could round to. So we're going to round each fraction to 0, 1/2, or 1. Those are our 3 values that we can possibly manage. Okay, that's it. So what we're going to do is use a number line that's going to help us. So if we're good with graphing, if it's closer to 0, we'll call it 0. If it's closer to 1, we'll call it 1. If it's closer to half, we'll call it a half. Okay? So anytime you have a number, you're going to look at it this way for the half. I think finding a 0 and finding a 1 is pretty easy. But when it comes to half, if your numerator is about half of the denominator, then you're good to go. So here's what I'm talking about. So remember we have 1/2. He has a lot of cousins. It could be 2 over 4. 2 is half of 4. 3 over 6. 3 is half of 6. 4 over 8. 4 is half of 8. 5 over 10. 5 is half of 10, and so on. So that's kind of our earmark for something that's going to be about 1/2. So let's talk about what this would look like if I tried with a number line. So let's just do a couple of examples, and directions are going to say estimate. So we've got 1/3 times 7/9. So I'm going to draw a number line. and we're going to put those three key numbers in: 0, 1/2, and 7/9. So what I'm going to do is try to figure out how to plot each one of those. So let's see. 1/3 is below a half. In fact, we've got, let's see, we had 1/3. Looks like, I think it'd be about right here, because then you'd have about 2/3, and then you'd have 3/3. So this would be my 1/3. Okay, and then 7/9. Oops, look what I wrote. See, if you guys were in class with me when I was doing this, you would say, Rosner, you made a boo-boo. That should say 1. All right, let's try that again. So 7/9. Well, half of 9 would be 4.5. So this is well over being halfway. So this is going to be closer to this guy, and there's my 7/9. So what I'm going to do is I'm going to say 1/3, pretty close to 1/2. That's going to be my compatible number for it, or my estimation. And 7/9 is going to be close to 1. So that when I multiply them, my answer, is going to be approximately 1/2. So I'm taking 1/3 of almost a whole, so it's about 1/2 of a whole. That's going to give me about 1/2. All right, let's do one more. We have 1/9 times 4/5. So this one is saying, I want a little teeny slice of almost a whole. So here's your 0, your 1/2, your 1. So I'm going to go ahead and graph these in. 1/9 is going to be way down here. 1/9. 4/5 is going to be way up here. So if I had to estimate, I want a teeny sliver of something that's not even a whole. This is going to be 1/9 is about 0. 4/5 is about 1. And that tells me I'm going to get an answer of about 0. Now I know you guys are thinking, how can I get 0? That doesn't make sense. Excuse me. Basically what it's telling you is the answer you get is going to be very small. Very small. Way closer to 0 than anything else. Okay? All right, good luck.